Welcome back to the channel, everyone. For today, we will be discussing one of the most popular theories in finance, which you can use to predict your stock market prices, which is the random walk theory. A prerequisite here is the understanding of NumPy and Matplotlib, and we'll also be getting some of the data that we have from Yahoo Finance. A random walk is a simple way of describing how something changes unpredictably over time, like the movement of a stock price or the path of a person wandering aimlessly. Imagine you're walking down a street and at each step you flip a coin. If it's heads, you take a step forward. If it's tails, you take a step backward. You have no idea which direction you'll go next, it's completely random. After many steps, you could be anywhere, but there's no way to predict exactly where you'll end up. Each new step doesn't depend on the ones before it, you're just reacting to the coin flip. In finance, a random walk is used to describe how stock prices move. Every day's price movement is like flipping a coin. The price might go up or down, and it's influenced by random events like news or economic data that are impossible to predict in advance. And just like you can't predict the next step in a random walk, the theory says you can't reliably predict where a stock price will go next based only on past prices. For this code, we need the Yahoo Finance package. So if you haven't installed the Yahoo Finance package, so you can run pip install yfinance, and if it's already installed in your system, we can import it. So for this, we would be needing NumPy and Matplotlib. Okay, so we have to create helper functions. For this video, we need to do three things. We need to fetch the stock data, we need to calculate the daily returns and the standard deviation. What we will be getting is the price data, but for the random walk, we need to predict the returns. And there's a calculation that we need to do for that, and we'll be using NumPy. And after that, we'll plot just to have a visual appreciation of how the random walk works. And lastly, we'll do our prediction using the random walk code. So I'll walk you through that. So first is we need to write our helper function, fetch stock data. So here we can define fetch stock data. Our ticker will be JPM for JP Morgan, but we'll do that, we'll supply that later. Okay, and basically we'll just return here the yf.download. Or maybe we could just, okay, ticker period. Maybe store this in. And we'll return the stock data. This stock data is what we need to calculate the returns and the standard deviation. So for this, just need here the prices, and for the NumPy function here, we need to do the NP_diff, because to get the stock price return, it's the price today over the price yesterday minus 1. So it will be NP_diff prices. Okay. Okay, and Okay, so now that we're done there, okay, write the helper function for the plot. Okay. So here the dates, the prices, the returns. Okay. And we need here to have 3 axes. Okay, and we'll attach 3 different plots to those axes, and subplots, 3 rows, 1 column with a fig size of 10, 12. Okay, and we'll be using just one plot data function for the real price and the predicted price using the random walk. So we'll just call this stock and simulated data. So for the first plot, it's dates for the x-axis, prices for the y-axis, and the label is, of course, price. It's either the real price or the simulated price, and of course here prices, so for the second plot, we'll plot the daily returns. So it's also a line plot, but so here instead of the prices, we'll use the daily returns, and of course the label will become daily returns. Maybe we want to also differentiate the color, make the color orange, because we don't want it to be the same color as this one, and the set title will be the daily returns, and the y label will be returns. If you're wondering why we're not labeling the x-axis, it's because it's going to be obvious that it's the date, because it's a time series. And lastly, we'd want to check the histogram of the returns. Okay, so for this one, it's ax3.hist. Okay, so if you've watched my Matplotlib video, you just replace the PLT with the axis. So here it's ax3, and then pretty much the same with the other parameters. And let the bins be 50. Here maybe you would like the color purple, and we're always a fan of alpha, so maybe make it 0.7. And okay, so notice this is supposed to be 2. Okay, 2. And just get this one. So ax3 would be histogram of returns. Or distribution of returns, that's better. And the y label, of course, is the frequency. Because the x-axis is no longer the time, we need to put in here an x label. So the x label would be the daily return. Okay, of course, to ensure that we have a tight layout, we will input tight layout and plt.show, because we didn't have the magic command for the Matplotlib inline. Okay, so x2 plot data returns. Okay, so now that we're done with our helper function, let's go and plot, or rather define our random walk function, which is why we're here. So here, generate random walk, and for this case we need to have the start price, number of steps, the mu or the mean, which we will assume to be 0 and 1. So let's generate the random returns. For the random returns, we will be generating it from the np.random.normal. If you've watched my NumPy video, you know that by default the parameters mu and sigma is set to 0 and 1 respectively. However, because we want to draw a random number or a random return based on the actual returns or the distribution of the stock that we are going to get, then we will be getting here the mu for the stock price that we've generated. And these functions that we're generating, you can basically just copy it and change the ticker. It would work fine. So we have mu, sigma, and the last parameter here is how many generation of that, or how many numbers does this function need to generate. So it's the num steps. Okay, so we have to start with an empty container first, or array, and basically it's really just np.empty, and then of course the number of steps, where we create an empty array that can contain this number of elements, the number of steps, and of course our price 0, or the initial one for this would be of course our start price. Okay, now this is the essence of the random walk, so please pay attention here. So for time step in the number or range of the number of steps from 1 to the number of steps, okay, the next price, or the price for that day, is equal to the price yesterday, right? Price yesterday minus 1. Okay, that's why we're starting with 1. Okay, the price yesterday times 1 plus the random return for yesterday. And I hope you see that it makes sense. Okay, because we're generating the price, or this is supposed to be prices, and then here. Okay, so this really means that the price for today is generated by the price yesterday, which is time step minus 1, because price time step is today. So the price yesterday times 1 plus the return generated yesterday. It's this simple, and of course here we return the prices. So now when we want to run this, we need to set our parameters. So our parameters is number 1, our ticker, would that be of JP Morgan, right? We want a JP Morgan because we think that banks might be a little less volatile than tech stocks, right? Of course, that's just an assumption. So we supply that from our fetch stock data function, and of course our ticker here is JPM, and we can check that. Okay, so YF is not defined, so okay, because we need to import it as YF. Okay, and then run this again. Okay, and now let's so we can quickly check that. Okay, so we have the stock data here. Now we want to generate the historical returns and historical standard deviation. and we will be calling on this function, calculations of calculate returns and STD, and the price is here, of course. So remember that it returns two arrays, right? Daily returns and daily STD. So that's why we have two variables here. You need to supply one array. So for example, for this one, for the stock data, we really just need to get the close values. So to get that, you have that, and because it just requires an array, you will get this. The dot values turns the particular series into a NumPy array. So we get that, and that will be our input for this one. Okay, and after that, you can verify that. So we could maybe print it here. So for example, ticker okay, and get this. Okay, it will just be one number. Okay, and I guess we can generate the random walk, but we might want to first check the plot to have a visual appreciation of that, which of course we will use to verify if our random walk forecast makes sense. Okay, so for the plot data here, we really just need to get, so for example, the stock data that you've generated will be this, right? If you get the index, you'll have the dates. So this is the dates. The prices would be the historical prices. So for the prices, it's really just the stock data, this one. So I think this one, we should have just stored it in a variable historical prices, and maybe just put it here, historical prices. And you can just use it here, historical prices and historical returns rather. So hopefully this works. Historical price is not defined because we need to, okay, so our function here, x and y, must have the same first dimension. Okay, so we have to trace this one. It's in this one, x2, dates and daily returns. Okay, because for daily returns we lose one observation, right? So I think for ax2 it should be how do we fix this? It should not include, it should not include the first number. So the way we're calculating the daily returns, if you would review this formula, is that we're getting the current price and the difference of the current price over the previous price. But the very first price that we have in the NumPy array doesn't have a previous price, and therefore that will return a none, or it will be excluded from the calculation. So therefore, to fix this, we need our dates to start in the second for the second date. So hopefully this should fix that. So let's see. Okay, so as you could see here, it's trending. The daily returns here. There are some days where the JPM stock had a very huge dip, and as you could see, while it's a little bit normal here, it's left-tailed because there are some days where it really had a very large. And ideally, when we're doing the random walk should just be from the normal distribution, ideally not left-tailed or right-tailed, but that's beyond the scope of this class. So now let's generate the random walk. So for the random walk, we really just need to call on this function, okay, generate random walk, okay. Now the start price should be, so for this one, let me just teach you how to get the start price. If you are predicting the start price should be the last price of this series. Why? Because there's no use for you predicting something that has already occurred, right? So meaning that you want to start at the last available known price. So this will be your start price. Okay, so this is your start price. The number of steps in finance, there are 272 trading days in a year. So 272 is like 1 year. The mu would be, okay, just the mean of the daily returns that we have calculated. And of course, the STD would be the NP standard deviation of the daily returns. Okay? Okay, sorry. We don't have a daily returns, or we call that the historical returns rather. Okay, so now, so this mu should be mu, and this sigma should be STD, and the random return is not defined. So here in our function, random, okay, because it's random returns, so random returns, okay, random returns, okay, and ideally we should put it in the forecasted prices, okay. And to really see the plot, we call on this function again, but it needs the daily returns. So basically you also need to calculate okay, the forecasted prices. So we call on that function that we have created, calculate returns, okay, and here we have the forecasted prices and forecasted returns. Error now. X and Y must have the same dimension. Okay, why is it? Okay, because here for the dates we should have, okay, for the dates here, let's just replace it with okay. So this is supposed to be the day, right? And if you would look at, okay, so now it's a little bit more normal, but if you look at the trending or the trend of the price, it somehow simulates the historical one, and that shouldn't be at all surprising because we did use the parameters or the characteristics of the historical prices in predicting. So there you have it. If you have all these ingredients, you can perform a random walk forecast for any stock that you want. And that's it for this video. Thanks for watching.